Hello everyone, this is Adel from Engineering. In this video we'll go through the ESD gun with PCB tutorial available within Charge Plus. Here we have our model with the defined ESD gun, and we have a PCB inside of plastic enclosure. We'll start by setting up our breakdown region. We will use nonlinear air chemistry. And if I expand bounds, minimum and maximum, I set minimum X to -6 millimeters, minimum Y to -8, and minimum Z to -24. For maximum X, 32, for maximum Y 2, and for maximum Z, 10 millimeters. Now we can click on the green check mark, and here's our breakdown region, which includes the PCB, part of the enclosure, and the gap between the ESD gun tip and the enclosure. Now let's hide the breakdown region and assign a material to our enclosure. This is plastic enclosure, so let's go to materials, select isotropic. Here I'll name it plastic. Let's expand general, and I'll set the relative permittivity to 4, and set the electric conductivity to a very small value. I set it to 1 e-12 Siemens per meter. Now with the select surface tool, I'll go and select enclosure, and then click the green check mark. And now we have our plastic material defined. Now the next step is to define our variable grid. So if I go to domain and click edit, and here expand lattice, step size, you can see that our mesh cell size is 2 millimeters. And to be able to resolve the traces on the PCB, we need to set the step size to 0.2 millimeters. For that, we will set our variable grid around our breakdown region. So here I'll expand minimum and maximum, and I'll use the same values as we did for the breakdown region. So for minimum X, -6 millimeters, for minimum Y, -8, and for minimum Z, -24. For maximum X, 32, for maximum Y 2, and for maximum Z, 10 millimeters. Here we'll set the step size to 0.2 millimeters on X, Y, and Z. Now we can click the green check mark, and this is our defined variable grid. We can now hide it, and let's assign some voltage probes. So I'll go and hide the enclosure as well, and the first voltage probe I assign will be between the ESD gun tip and the PCB. So here let's select voltage probe. I'll name it PCB voltage. I'll select the first point on the ESD gun tip and the second point on the PCB. Now let's set a second voltage probe across this resistor R1. But first let's check its properties. This is a 1 kilo ohm resistor. So here let's go to voltage probe, and I'll select both ends of this resistor. Now we can hide our voltage probes, and you can see that we already had two defined probes, a voltage probe across the charging capacitor in the ESD gun and a current probe on the ESD gun tip. Now let's add an animation probe to look at the currents on the traces during the ESD event. So here I'll select animation probe. I'll name it animation. We'll keep the probe type to electric current. And here I'll set the start time to 20 nanoseconds. Now let's select the top surface of the PCB and click the green check mark. The last probe we want to define is the 3D air conductivity probe, which will show us if there is any secondary arcing due to the fields building up inside of the enclosure. So here I'll go to Field and select 3D probe. I'll name it 3D and change the probe type to air conductivity. And let's set the bounds using the values we use for the breakdown region. In millimeters, -6, -8, -24, and for the maximum, 32 to 10. I'll set the start time to 20 nanoseconds and set the step time to 0.2 nanoseconds. Now we can click the green check mark, and here's our 3D probe. Now we can go ahead and mesh the model. So I click Mesh. Then click Start. And click Run to start the simulation. Now that the simulation is complete, we can go ahead and view the results. Here I plotted the source voltage, which is 15 kV, as well as the voltage of the discharge that we are getting from the ESD gun to the PCB. Here we have our current waveform, which depends on the dielectric enclosure, the location of the PCB, and the impedance of the PCB. I also plotted the voltage across the resistor R1 on the PCB. Here you can see this sharp impulse around 2.4 nanoseconds, which is when the ESD strike hit the board. Now let's take a look at the air conductivity. Here I'll change the scale to 2 Siemens per meter. And as you can see, we have an arc from the ESD gun to the enclosure and a secondary arc from the enclosure to the PCB. Here we have our results from the animation probe that we placed on the surface of the PCB. So here you can see the current on the traces, and I exported this animation as a GIF. In this video, we went through the ESD gun with PCB example. Thanks for watching, and see you in the next video.